All right, I think I found it. Let's start. I found the document. Consider a sphere of a radius A with a uniform charge density of unity. Calculate the total charge contained by this sphere. Consider the case of non-uniform distribution of charge density, functional form, which means that rho of R, K, 3 minus R squared over A squared for the same sphere. Evaluate the constant K. 15 marks for question number 1. So the uniform charge density is given by that rho, which is equals to 1. Why is that density equals to 1? If I may ask, why is the charge density equals to 1? That rho P equals to 1. In a sphere of radius A, why is the charge density equals to 1 plus? Quiet now.
I'm not sure, sir. I'm not sure why it's 1.
What is the charge density?
Of unit.
Yes. If we say you are united, you are 1, isn't
Hey, hey,
it?
okay.
If you are united, you are 1, isn't it? Is
I
that not
didn't
so?
applies in physics as well.
If you are you are united, you are 1.
Yeah. Okay.
That's why charge density is 1. So the charge density of unity is
1.
you are a whole, you are full, you are complete. It means 1. 100%. 1 over 1. 1 is full. Yes. So in case the charge density of unity is just rho equals to 1, calculate the total charge Q in this sphere. So the total charge Q by this sphere, which means you are just looking for the value of Q. Q is that charge density times volume. And remember, we were told that this surface is a what? A sphere. A sphere, the volume of a sphere is 4 over 3 pi r squared. Where the radius is A, we know the volume of a sphere is 4 over 3 pi r cubed, not square. Where now, if the radius A, which means where there's R, you replace with what? A. That's what it is. Where there's the charge density of unity, you replace with what? With 1. So your charge is 4 over 3 pi A cubed. Any question?
No.
Then the second one, it's asking for B. Consider now the case of non-uniform distribution. So the first part was for uniform distribution, and the second part for non-uniform distribution of charge with a density functional form, non-uniform distribution of charge. So that charge density, it's having that equation. The charge density is having that equation. Rho of R is equals to 3 minus R squared over A, K multiplied by a constant, K. So evaluate the constant. So we are looking now to solve the value for K. What we want to do now. So starting point, we know that that is the equation. That is what we are given, 3 minus R squared over A. 3 minus R squared over A. So don't mistakenly think, remember, there's a difference between 3 minus R squared over A squared and 3 minus R squared over A squared. Remember here, it was not put in bracket like this. There are no brackets. So which means it's R squared over A, which is this one. So be careful of how you interpret these things. If you mistakenly interpret, which means you make it as one denominator, then you wrong. You must know that division starts before subtraction, odd mass. So 3 minus R squared over A, it looks like this. So this is just a constant, ignore the factorial one. Just ignore the K factorial. So it's just K. 3 minus R squared over A is the total charge. This is our function for the charge density of non-uniform distribution. So if I want Q, I integrate the volume, rho dV over that volume, rho dV over that volume. So what is my rho and what is my dV? So you replace rho dV. So we are replacing what is rho. You replace your rho is K, and then dV. How do you replace dV? dV, I told you, you replace dV with what? How do you replace dV? If you want to replace volume is what? What is volume, class?
Is dV.
We want to find the charge, and we are given the function of non-uniform distribution of charge. So if we integrate Q, if we integrate that density function with respect to volume, V. So here we are only changing the dimensions, dV in terms of dr, dV in terms of r, dV in terms of r. So that is what we want to check what happened here. Because the K, we can see the K. Are you seeing the K, where it's coming from? The constant. So if I introduce the integral here, I also introduce the integral this side, which is this part. And remember, K is a constant. That is why it's outside the integral. They've pushed it outside the integral. And then why are we integrating from 0 to A? It's a sphere. A sphere starts from radius of 0 up to A. That's why we're integrating with respect to 0 up to A, the radius of a sphere. Then the dimensions of changing dV. So here dV is equals to 4 pi. dV is 4 pi R squared dr. How did we find this one? If I'm to ask you, my, what happened? My Phy and Clementine, is Clementine there? She's quiet nowadays. So what's happened? My, how did we find that dv? This one.
Which one?
This one. This one. This dv all of a sudden changed to dr. What happened? What is the volume of a sphere, my?
4/3 pi r squared.
Not r squared. What is volume of a sphere? V is not r squared. R cubed.
R cube.
Sorry. R cubed. So differentiate v with respect to r. What is dv? dr. What is dv dr?
It's 4 pi r squared.
4 pi
R squared.
r squared. It's 4 pi r squared. Now make dv the subject of the formula.
We multiply both sides by dv.
By dr.
By the r, sorry. Yes.
So it will be 4 pi
r squared. The
r
r.
squared dr. 4 pi r squared dr. That is this dv, which is here, which they've replaced. Instead of writing dv, they replace dv with 4 pi r squared dr, so that we can integrate with respect to r, since we are already having r there. So instead of writing dv, I wrote 4 pi r squared dr. Any question?
No.
Yes. 4 pi r squared dr. But 4 pi and k are constants. You can take them outside of the one.
Integral sign.
Why are you integrating from 0 to a? They are integrating from 0, the radius of the sphere, it's 0, to the radius of the sphere a. Those are your limits. So r is ranging from 0 to a. It's inside the sphere. Any question? Any question about the integration part? How we are going to set up that integral? How are we going to set up? So if the total charge is contained by this sphere, which means it's inside, which means it's 0 to a. So 0 to r, and the radius is inside. The maximum is the end point of the radius. So a and r are equal. So let's integrate now. What do you do when you integrate with respect to r? Same applies to what was happening the other day, the integration part. We are integrating this with respect to r, then you substitute the limits. So your 4 pi k stays outside the integral. 4 pi k stays outside the integral. Then automatically you put a what? A square bracket to say, I am done with the integral. I don't want integral anymore. What is the integral? What is the integral of 3 with respect to r? What is the integral of 3 with respect to r? Integrate. What do you get? And before you integrate, are you seeing that the r squared is multiplying everything that is inside the bracket?
Yes.
Did you see it?
Mm.
So if you want to make your life easy, you do like this. to say, what is the integral? This is one would be easy for you to integrate from 0 to a. Then the integral of 3r squared minus the integral of r to the power 4 over a squared. Then you say dr. dr, like that. Then let's integrate. The integral, what did you differentiate for you to have 3r squared? The original was what? What was the original with respect to r? If you want to get 3r squared, what will be the original? Before I get 3r squared after I differentiate, what was the original before I differentiate?
Which one, say?
So before you, what is the integral of 3r squared? What is the integral of 3r squared?
Isn't it r cubed?
R cubed. Yeah. We put your r.
Power 3.
Then what is the integral of r to the power 4 over a squared?
R to the power 4.
Over a squared. What was the origin?
You are multiplying with what?
What is the
Everything.
integral of r to
The
the power
R
4 over a squared? Minus what?
minus 4 minus into 1 over 4 to the power R5. Man.
5. Over 5, not over 4.
Over
R5
5.
over 5.
Over 5.
Right. Then you replace the limits. You replace the limits.
0 is to a.
Then what do you get?
We're gonna get a to the power 3 minus a to the power 5 over 5 a squared. Multiply by 4 pi k.
So here r is equals to 0 to r equals to what?
A.
R equals to a. This is how you do it. So if r is equals to a, what will be the final answer now? R is equals to a and r is equals to 0. So for r equals to 0, everything vanishes, isn't it?
Yeah.
Then we don't subtract anything. We are just subtracting 0. Then the first integral would be 4 pi multiplied by that k bracket. Where there is r cubed, you are saying r equals to a. So it would be a what?
Cube.
A cubed minus. Where there is r to the power 5, it will be r to the power 5, which means it will be a to the power what? 5 over 5a squared. So you subtract the exponents. 5a squared, the one on the denominator and the one on the numerator. So which means you are only left with the a on the numerator. You subtract the exponents. 5a squared on the denominator. So which means the simplified version of a
It's
to the power 5 over 5a squared. We are just going to get a to the power 3, which means
over
we have subtracted over 5. That one is the simplified after we have dealt with the a's. Then that is the value of your what? Of your q. But you are looking for a what? A constant. Remember, your mission is to find the constant what? The constant k. Is it? Your mission is to find the constant k. So if we are to replace everything there, like what we did, to say q is equals to 4 pi k, which is equals to that. So our mission is find the value of that k. How will you find the value of the k? From where we are, how do you find the value of the k? What was our q? What did we find as q? 4/3 what?
R cube.
Okay. 4/3 r cubed. Question is indicating that evaluate the constant k. So you evaluate. So now we've considered that there is a case of non-uniform distribution where the total charge functional density is given by that. So now we want to evaluate the value of that constant k. What is that k? So before we found out that it's 4 pi over 3a cubed. So let's replace that. So 4 pi over 3 over 3a cubed is equals to, on the right hand side, what are you having?
Four pi k.
We are having
4 pi k bracket a cube minus a cube over 5.
So we can factor out the a cubed because it's constant, isn't it? So which means we are going to get on the right hand side, which means we have 4 pi k, 4 pi k on the right hand side. Then if we factor out a cubed, is common. So I can factor out a cubed, 4 pi a cubed, then bracket
Can't
1
we?
minus 1/5. 1 minus 1/5. So it would be 1 minus 1/5. 1 minus 1 over what? Over 5. Okay? Which is the same as saying. What is cancelling out? What is cancelling out? 4 pi is cancelling out, isn't it?
An a cube.
4 pi is cancelling out with 4 pi. A cubed is cancelling out with what? A cubed. Is that fine? So we are left on the left hand side, 1 over what?
3
Is equals to
k 1 minus 1 over 5.
k multiplied by what?
1 minus 1 over 5.
Which is 4/5. So if you want to get rid of the 4/5, you multiply both sides by what?
5/4.
5/4. Then also this side by what?
5/4.
5/4. So what is the value of the k?
5/12 equals to k. No wonder it's 12 marks here.
So you have to again simplify. Great. Once you get your answer, then you simplify. Any question? The reason why they got 16 pi here is because of the inside. If you want to find the denominator of 5, which means this one, it's going to be 5 a cubed over 5. 5a cubed over 5, like this. So 5a cubed over 5, it's just a cubed. So what is 5a cubed minus a cubed, which means you are left with 4a cubed. So it will be 4 pi. How they got that answer? It's 4 pi. 4 pi k multiplied by 4a cubed, which is inside the bracket. 5a cubed minus a cubed, 4a cubed over 5. So if you multiply 4 by 4, you get 16 pi k a cubed over 5. Then you equate this one with the q that you are having, isn't it? Hello? I am showing you how they got this one. We did not use this step of here. For us, we factored out a cubed, but them, they used this method of manipulating a cubed minus a cubed over 5. The answer is 4a cubed over 5 inside the bracket. That is what they are going to get inside the bracket. Then you multiply by 4 pi k outside the bracket. If you solve what is inside the bracket, you get 4a cubed over 5. Multiplying numerator times numerator, it gives you 16 pi k a cubed over 5. This one. Once you are done, you say q, that q is equals to 16 pi over 5 k a cubed. Then lastly, you still arrive at this formula where k is what? 5/12. Just one and the same thing, different method of solving. Instead of them factorizing like what we did here, we factored out the common factor. Them, they just simplified as it is inside the bracket. But we arrive at the same answer. Let's move on to number 2. Any question with number B, which you want to ask? Where you feel you want to ask? For B. Is it fine for calculating Q? Okay. Then for B, it's saying let the electric potential V be independent of X and Z, and the gradient of V is equals to 10y in the Y direction. The gradient of V is 10y in the Y direction. If V is equals to 5, at Y is equals to 0, then find V in terms of Y. For V is 5 if Y is equals to 0. And we have been told that that V is 10y in the what? In the Y direction. But it's the gradient of V, not V itself, the gradient of And also if v is 5, y is 0. V is 5 at y equals to 0. Find v in terms of y. So I want to integrate. Then you find the electric field where the potential is minus 5xy. Same thing, what to integrate. So what are we given? V is independent of x and z. In other words, v does not contain what? X and z. Is that clear? Hello?
Yeah. Hello.
V does not contain x and what?
And Z.
Independent. X and z does not contain x and z. But we are told that the gradient of v is 10y in the y what? Direction. So now we want to integrate. So we can find v of y. So which means gradient of v, the formula was that dv dy is 10y. That's what happened. They say grad v, it's 10y in the y direction. In the y direction. It's 10y only in the y direction or in the j direction. They can also say 10yj. This implies that grad v is the same as dv dy. So dv dy is equals to 10y. That's what we are given. What is dv? Then you integrate. First, you separate the equation. You make it a separable differential equation. That's how you do it. You make it a separable differential equation. How do you make it a separable differential equation? You say dv is equals to 10y dy. That is the first equation. Multiply both sides by what? By dy. Then next you introduce the integral. The integral of dv, get v of y. Then the integral of the right-hand side, we are integrating. Any question on how to integrate? So since v is independent of x and y, which means you're only going to write this is v of y. But if it was not independent, we are going to write v of x, v of y, v of z. If it was having all the functions, you integrate. But since it's only having one function, y, which means we just write v of y. So v of y is equals to, you integrate 10y. What was the original? The original was 5y squared. Then you add plus c, which is a constant. After integrating, you always add plus a constant c. Always, after integrating, whether calculus, always add plus c. Unless the integral is a definite integral where you are not supposed to say plus c, but you are putting limits. V of naught, we have been told that v of naught is 5. So you want to solve for that constant c. So you are solving your differential equation, substituting the initial conditions, which means v of naught. Remember, it's v of y. So v of y, we have been told that v of y is equals to 5. So if that v of 0, y is 0, sorry, v of 0. So what will be the value? So v of 0, we have been told when there's that v potential, electric potential is 0, the value there is 5. So you substitute that initial condition into your differential equation. Yeah. V of naught is equals to 5. So you are substituting there. So when I put 0, which means V of naught is equals to 5. So I'm replacing this one. So where there's V of naught, I put 5. So you'll be saying 5 is equals to 5 y squared. Where there's y, I'm putting a 0 squared. 0 squared. Where there's y, it's a 0. Because this y is inside here, which is a 0. Y is 0. Plus c. So automatically, that's how you find that the c is a 5. So the equation that you are looking for electric potential is this one, where now the constant, it has a value because you have substituted the initial conditions. V is equals to 5y squared plus 5. Any question? Any question? Then for B, now for B, you want to calculate the electric field where the potential, you want to calculate the electric field where the potential V is equals to minus 5xy. So where V is equals to minus 5xy. So this is what you do. Your V is equals to minus 5xy. So the electric field, the formula says the electric field is equals to minus grad V, minus grad V. So let's calculate what is minus grad V. So if you are given your V is minus 5xy, this one, it's a function of x and y, which is the electric field in the region where the potential V is minus 5xy. So if you are calculating that electric field, E, you must know the definition. E is always, this formula must know it by heart, minus grad V. So which means if I want the partial V with respect to x, we are differentiating V with respect to partial V with respect to x, which means you're going to get minus 5y. You differentiate this V with respect to y. The same V, you differentiate with respect to y, you still get minus 5x. Differentiate again V with respect to z, it is 0. So partial x, partial y, partial z. All right. Which is equals to 0. So the question itself, your E is minus grad V. That will be your electric field. So which means my E as a vector, remember that E as a vector, my E as a vector, right, is equals to, in the X, it's minus 5y. You can put a comma, or you can write that in the what? In the I direction, or you can use in the X direction as a head. You can call it in the I direction, unit vector with an X, then minus 5x in the J direction with the head. And also lastly, plus 0, which means it does not have a Z component. Plus 0z, still 0. You can leave it like this. X. Any question? Any question? E. There it's bold. Here it's a vector. Whenever you see it's bold, it means it's a vector. This E is a vector. Grad V. So we have found the negative of grad V. E is minus grad V. But since there is a negative grad, this negative, which was already there, was for differentiation. So which means if I say negative grad V, I have it. So what will be the negative of that grad V? Which means you are supposed to correct that, which means negative of this, negative of this E, which means you are putting a minus outside. Putting a minus here. Minus. It's negative grad V. So minus grad V. So what was grad V? That is what we have obtained. So the minus, so the final E, after I put the negative, the correct one will be E. Then R is equals to positive 1. 5y in the I direction plus 5y, 5x in the J direction. After you've introduced the negative. Any question? Are done. Is it fine?
It's too much information, sir. This paper is
What is
different.
difficult? Just to integrate and to this one is easy, this one.
I think it's because I'm tired. Remember, I was writing today. So
Finish the other ones tomorrow. Explanations, you can just go through them. Then tomorrow, 4, 5, and 6.
okay. So you have a lot of recording that you haven't sent.
How many recordings? You said only 2 and these ones for today.
I remember that on Monday we did calculus. Do you remember question 6?
Yeah, but you must now put your things down into writing so that I go and confirm which date. You just tell me the module code and the date. That's all.
Okay.
Forward.
No problem.